Okay, back. As you can see, I put the values for this one in since the last video. Going to work on the next one, which is going to be our last one before finishing it all up. This one, as you can see, isn't really that hard at all. So, A1 to A4 is going to be the minimum from of k is equal to 1, 2, 4, because it's our j, so 4. Okay, our first k, and I normally don't write out k's, but I'm doing it for you guys, is going to be 1. And we're going to have our 1, 1 plus m 2, 4. Wow, I really hate my screen. 2, 4 plus d0 plus d1 plus, why am I writing pluses? I only meant to write 1 plus, times d1 times d4. There we go. So this is the first one. Once we have this, we'll do the same thing for all the rest, okay? I'm going to do that really quick. So an easy way to check your work is going to be, this will always stay the same. These are the only values that are going to change. And it always ends up being 1, 2, 4, and then 3, then 4. So as you can see, it always kind of fills it up, and like I told you last time, it just shows the options you have. This is the only things that change. So it's pretty easy to keep track of -1. Whoops. So it's 1, 2, 3. So yes, this is the only things that'll change. And this is what your whole problem should look like. And then obviously we're just going to fill in our values for each of these. I don't want to write it all out, but I am going to. So this is a 0 because if you remember, 1-1 is just going to be our A1. So it is automatically a 0. This is 288 plus our dimensions 2 times 8 times 4. I'm writing really big. This is 96 plus 96 plus 2 times 6 times 4. Okay, I'm going to show this one because it's one where you haven't seen where both m's have a value. So m1, 2, so 1, 2 has a value 96. M at 3, 4, 3, 4, 3, 4 has a value of 96, as you can see. So that's why they both have 96. Now you're going to go back to the one that you're normally used to, where this is 144 plus at 4, 4. As you can tell, this is going to be a 4, so it is a 0. And then plus the dimension, so 2 times 4 times 4. And I am just looking at these dimension values, but I can't split my screen for you guys. So you can't look at them at the same time unless you've written them down, which good on you. Okay. Using a handy dandy calculator, this is 352, 240, and 176, if I can write correctly. So 176 there is the smallest value, as you can see. So 176 is our chosen one. At 176, k is equal to 3, so that is what our p is going to equal, 3. I just said it was 176 was our m value, and then we're just going to look at m13 is M13, I don't have them memorized, is 2 by 4. M at 4, 4 is, let's see, a 4 by 4. Wrong page. It's a 4 by 4. Get rid of the like dimension, you end up with another 2 by 4 matrix. So this final one is a 2 by 4 matrix. Okay? And this is our fully figured out optimal matrix chain whatever thing. And now we need the fully parenthesized version. Okay? So what you do is, I am lazy and I just kind of write them all out first. So let's do it in, let's draw it in black. Okay, so all our dimensions are A1, A2, A3, A4. Okay, this says that we chose to have it after 3. That's where our point is going to be. Our parenthesis is going to be after 3. Because if you remember, we chose to have 1, 2. Well, no. We chose to have M13, and M13 is A1 to A3. So we chose to have, when we chose this option, we chose to have A1 to A3 and then multiply that by A4. So that's why we're going to be putting our parenthesis here first. Okay, so A4 is taken care of. Now we have to look at A1 through A3. We have to look at this section. So A1 through A3. A1 through A3 says 2. So that means that we're putting our position after 2, our new parenthesis. So we have one there. And then as you can see, it's just A1 times A2, so obviously we know that these are being multiplied by each other. Okay? And that's your fully parenthesized solution. Easy, right? You just put your parentheses depending on which one we chose. Because like I said in here, this is where you're choosing where it goes, your different options. And this is the visualization of it. Okay? I draw them on the bottom at this point, and then I start pairing them up. So we first do let me do a different color. We first do this, right? And then this is multiplied by this. So this is then multiplied by this. And then all of this is multiplied by this. And there you go, your execution tree. And you're done. That's all that matrix chain is. Now, heuristics themselves are a little bit different. Heuristics are going to be things like choosing the smallest dimension first. So I'm just going to use this as an example. Okay? The smallest common dimension in this heuristic would be 4. So you would multiply these first. Then you would find the next smallest. The next smallest would be 6, right? Because you'd end up having 2 by 8, 8 by 6, and then a 6 by 4. So the next smallest would be 6. And then you would have a 2 by 8 and an 8 by 4. And that's all that heuristic is trying to tell you. When it asks you to do the smallest or the least inner dimension, that is all it is asking you to do. Okay? Not that hard. Another heuristic is going to ask you to do, another heuristic could ask you to just be greedy. So it will be great. Wow, I can't type. It will be like the greatest cost. Okay? Then that means you're really just looking for the max, honestly. So instead of finding the smallest multiplication, you're just trying to find the biggest one that you can do together. So, for example, you're going to see, would this cost more? Or would this one cost more? So would it cost more to do A1 than A2? Or would it cost more to do A2 and A3 together? Or would it cost more to multiply A3 by A4? Okay? Whichever one costed more, you're going to do that one first. Then you're going to see what A1 times, okay? So give me a second to write it out real quick. Okay, so I've written it out. So like I said, A1, A2, A3, multiplying them by each other. Okay, if we look at this, 192 is the biggest, okay? So then that means that we'll end up having A1, whatever, I'm just going to call it UZ for now because I'm lazy and tired. And then A4 left, okay? So then if you were to multiply these two, or these two, which one would be greater than each other? And then whichever one is greater, I'm just going to pretend that it was this one. This is now the biggest one. And then you'd multiply it by the next one. So it's kind of the opposite of what we normally do. Another one could be get rid of the biggest dimension first. So if we were to get rid of the biggest dimension first, that would just be our 8. So eliminate the biggest dimension first would be eliminate the 8, and then eliminate the 6, and then finally eliminate the 4. And that's all that one is. So heuristics are just different ways to look at the problem and to do it. It's not the optimal way, but it is a way to do it. So what he's asking you is to prove, what you could be asked is, create an example of giving some arrays with some dimensions that would not be the optimal way. So a way where doing the optimal matrix chain will be a smaller value than this. It's just proving it, that it doesn't work. Or maybe prove a way that it does work. So, yep. Hope this helped. I kind of doubt it did, but oh well. Bye.